All right, so welcome back. This is stage number 2, and we are going for the guidelines. And standards and best practices will be the things we will touch here today, because those are essential for the safekeeping of our most valuable people and assets. So, question is, do we always follow them, and what we can do better? There is a talk, and the talk is called Guidelines for Fire Protection Engineers in Selecting the Optimal System Selection to go for. So which one is it? Fire safety expert from DANFOSS, Márton Horváth, is our guest speaker. Please welcome. Oh yeah, some kind of support we also need. Thank you very much. Márton,
thank you.
Good luck.
Labdien. Nice to meet you here this afternoon. I hope you are still motivated to listen something new. And when I selected the title of my presentation, actually it's not only for firefighting safety engineers, but of course consultants, investors, facility people, because nowadays, as you see on the exhibition, there is a lot of different systems, and which one to go for? Well, it's a question. You can see the compass on the presentation in the top. We all know there are gas extinguishing systems, water mist, especially I will talk about high pressure water mist, foam systems, sprinkler, and of course many other. Just briefly about my position and my experience. I've been working more than 25 years on the HVAC and fire safety field. I'm also a legislated fire safety designer, member of the Hungarian Engineering Chamber, and I've been working as a project manager inside the Eurotunnel. So I have many aspects about fire safety systems. Maybe this presentation will give you some new ideas. I hope it will. And at the end of the game, of course, you can ask questions. But I will have one question, and who knows the right answer can win this little present, which is a red cap DANFOSS. So our agenda today, the easy part, we will go very fast. High pipe storages with ESFR. I hope everybody knows that this is a good selection. Foam systems, again, conventionally widely used systems. And then we move to the more interesting part, where I try to compare high pressure water mist with other systems, analyzing different fire risks. And when you will meet maybe in the future those fire risks, then it might pop out in your mind, oh, I have heard something about high pressure water mist. And then maybe we will again join and continue a valuable discussion. So high-rise buildings, hospitals, we have also some questions earlier had about hospitals, how and why to use it in hospitals, high pressure water mist, data centers, that's a mega trend, you know very well. And paint booths, car factory is also a kind of risk which we will analyze today. So this is the easy part. Here the takeaway is that we have fire control, fire extinguishment, or fire suppression. Which one is the main goal? This is always the first question you have to raise, like when you started designing or specifying your system. Those very reliable suppression sprinkler system with a mega quantity of water will probably suppress your fire, and it is widely used, of course, for high pipe storages. Here, I don't give more ideas, because at this moment I think this is the best solution, and many of us follow this. About hydrocarbon storages is again something a very typical high risk areas, industrial applications, or hangars. You could see also hangars can be protected by foam system. Here I don't see too many options as to use, like the foam systems which mostly widely is used on the world. But let's move on to the more interesting part, because this will be rather something maybe new to you. Very fast we'll go through the basics of the high pressure water mist and the technology which is breaking down the water droplets into tiny little droplets, make it more efficient, make the cooling effect really very effective. So when you will see during my presentation those spider diagrams, don't be afraid, it's not complicated. The better is the system, the more you are in the middle. And the standpoints, when I select the standpoints, it's like weight of system. High pressure water mist using very little water has a tiny little pipe. It's clear. Weight of system, you could see the red high pressure water mist is in the middle of the line of the spider web. Acceptance by insurance. This is important for the end user when you are trying to find a good selection. High pressure water mist is getting more and more accepted by insurance, but for sure, as sprinkler has more than 100 years of experience, then for sure sprinkler is rather in the middle. Lifespan of a system. We are using high pressure water mist stainless steel pipes. You can come to our stand and check yourself. It's no wonder stainless steel pipe has a longer lifespan like a conventional sprinkler painted pipe. So you can see it's more in the middle. Risk covered by standards. Well, sprinkler is again rather widely used, so here we have to do something more. And the always important question, the total investment cost. And this is where I will stop sometimes a little bit more longer, because you can expect that high pressure water mist is normally more expensive. Yes, and that's the case. If it not be, it would be so easy to sell. This is my challenge. So here is a short video. Can you run the video, please? It's just a combustion triangle to understand why high pressure water mist is using less water like a sprinkler system. Because, for instance, I think it will start with the gas. The gas extinguishing system is taken away. If you take one piece out of this triangle, the fire is put out. Gas extinguishing system is taking out the oxygen. The sprinkler system is taking away the heat, and the high pressure water is taking away both. And this is the main reason why we use much less water to result in the same or even better performance like a conventional sprinkler system. So what happens? A small droplet is become to steam near to the fire, and with that it expands to 1700 liter, and then it's reduced the oxygen. So this is how we reduce the oxygen, only near to the fire. So it's very important that we don't need a concealed area like a gas extinguishing system to reduce the oxygen. The water droplets will just reduce the oxygen concentration in the middle, in the near to the fire seat. So yes, we can take the next slide. It's really understandable. Can you run this short video? This short video, and we move on to OH3 fire risk, which is a conventional storage application, solid shelves, which of course are worse because the water cannot penetrate to the shelves. So you see the high pressure water mist and the sprinkler, and the two videos running at the same time. Honestly, the best marketing video ever we have used to convince people not decided about system is to see. And here, you remember at the very first I told you that fire control. Here our task is to control the fire, which means that the fire is not spreading to the next, and therefore we are controlling it, and in fact the fire brigade will come and put out the fire. But you can see the same fire load is in both cases, and you are doing the sprinkler according the density with the standards, and you could see that the fire expanded. So our high pressure water mist using 30% less water, 10 times less weight, not only the steel pipe but inside the water. And the pressure, it's 60 bar. You could see that the pressure in our case is 60 bar. So this is water mist. I think I don't need to tell more about this video. You have seen it. So for the OH3 application, when you are looking to the spider web, you see that the lifespan, we have been talking about the stainless steel, I'm not repeating myself. Amount of water, clear, less, weight of system, less, total investment cost remain us to tackle. This is also important, but sometimes the total investment cost has less value to an end user like you think, because reliability and the small water tank and all these circumstances make maybe more value. This is our job to evaluate the difference. Paint booth. Paint booths, where do we have those paint booths? Yes, car factories. At least I'm coming from Hungary, we have several car factories, Audi, BMW, Mercedes. Each car factory have paint booths. Those paint booths are not small, they are big. Earlier they protected it with foam or sometimes gas, but they are not concealed. You have a draft, wind there. Gas extinguishing system is simply limited, and the gas extinguishing system would limit the normal operation. So high pressure water mist, you could see a picture about the fire test. You could see a picture of how it looks like in the reality. And if you again look on the spider web, you will identify that the red water mist is much more in the middle. So the future is for water mist for paint cabins. I think this improves many times, and the new car factories are already specified with high pressure water mist, and therefore it's generating us, of course, a nice business. This is a rough story, and I'm pretty sure I will get some debates, discussion, why using water mist into data centers. It's a sensible question. Of course, you don't want water to a sensible electrical equipment. But this is a mega trend, gentlemen, ladies and gentlemen. And it's not anymore gas, but it's high pressure water mist. If you just take a look what is inside the data center, it's not only the data hall. You have diesel generators, you have storages, a number of different fire risks. Now, take into consideration that if you go with the gas extinguishing system to the data hall, what would you do with the rest? Use sprinkler, then use two different systems. And then we start to talk with each other, because it's interesting, FM, American standard, the new ones, already prescribe how to make a fire test, a one-to-one scale fire test for data centers, for various, I'm not only talking about water mist, and I'm trying to focus not to talk only about water mist, but also to talk about other systems. So inside this FM approval, you can have a sprinkler system. Sprinkler system is legally accepted by FM. Don't ask me why. There is a fire test how to make. Of course, aerosol is accepted, gas accepted, and high pressure accepted. Now, if you conduct a fire test according to FM with your system, then you have a certificate, legally you can protect it. The question is how you can convince the end user. Honestly, the big data centers, they are coming from West, America, UK, whatever. They are all now specified with high pressure water mist. And I show you the investment cost, because again, this is an important question. You could see the total investment cost is a standpoint, important standpoint, because everybody's sitting on the money. Insurer, of course, they don't want to give out their money or reduce the insurance only in case you have a certified system. So here, the total investment cost will be investigated in the next slide. What do we see here? And it's very important that we are talking about big size data center, 2,000 cubic meter. That's 400 square meter by 5 meter, for instance. That's big. That is where we start to talk and being more and more attractive commercially, like a gas extinguishing system. So what happens here? If you have a gas extinguishing system and you put the protected volume and on the vertical the investment cost, you will see the following, that you have a linear relation, you have a linear equation. It's missing there is missing from this presentation one thing. The square root 2 choreograph, if you would do the high pressure water mist calculation on investment cost, the turning point is at 2,000 cubic meters, because you have to buy the pump unit, but then after, if it's bigger, you just put more nozzles. So the bigger is the data hole, the cheaper we are compared to gas. Something is missing from this presentation, I'm sorry, the characteristics of the high pressure water mist cost. So yes, as a takeaway, if it's enough big, I'm not talking about small data centers or small data halls inside an office building, go for gas, it's a very good solution. But if it's getting 2,000 cubic meter volume, try to think how much gas you need. And then we try to talk to each other. Hospital, I don't know if we have, we have here the colleague who was asking about hospitals. Yes, tiny little pipes, clean water, small water damage, reliable system. You can use pre-action system to protect, for instance, inside a hospital, an X-ray or MRI or an operating theater. So you can have all of these area, a parking garage. Excuse me, here is a little picture showing you all the risks, different risks inside a hospital. So are you interested to use 3 different extinguishing system, maintenance complication, or check if there is a solution, one solution, and that could be high pressure water mist. Because of the hygiene you have in the hospitals, you are looking for clean and long-term stainless steel piping. So when you are looking on the investment cost, beside of clean system, lifespan, whatever I explained on the spider web, again we will result about total investment cost. And the next slide is about, I made a total investment cost for a hospital recently in January. I am having at least 10 different hospitals in my region. I'm driving Central Europe and Baltics, and now I win a hospital project in Georgia. Just think on that, Georgia, they are moving on with the hospitals to have high pressure water mist. And total investment cost. This is a quite new and I think interesting chart. Initial cost, how much system cost? Sprinkler is cheaper. You could see I received the sprinkler price for the Ljubljana hospital, 761,000 euro. I made my calculation about this hospital, 1 million euro, and then you have life cycle cost. The facility people at the hospital told me, we like your presentation. It's really nice, but how much does it cost? I send them how much, but okay, but we are thinking long term. Can you make a long-term life cycle calculation? Okay, I can. I did. So this is probably a reality. So you could see that if you are thinking for long-term solutions with the stainless steel piping, again, you can give good answers to your customer. It's still not a one-way road. It can be still sprinkler, but this communication, if it starts, then we are here to help you. High-rise building, I think the high-pressure water mist and the high-rise building, they are kind of synonym to each other. You have to carry water to 200 meters. Last week I received an order from Bulgaria, 210-meter high building. We started the discussion on sprinkler, like again here you can see the comparison, lifespan, clean system, weight of system, and the total investment cost. The higher is the building, the more complicated is the sprinkler system. So the higher we go, the better chances we have with high pressure water mist. And honestly, the upcoming high-rise buildings in my regions are getting more and more frequently already specified with high pressure water mist. So if you have in your experience some high-rise buildings, just contact us. We will help you to guide you through. Here is a picture, the Belgrade, 155 meter. And what interesting that was in Cyprus, this high-rise building, that if you compare the two charts, you will, the pointer, sorry, is not moving on this, but you free up a lot of space for the tank, because if it's 155, 200 meters high-rise, then you need an intermediate tank. And you free up that area and you make luxury apartments, you win money. So it's again investment costs and ideas. And of course you have one riser instead of having many different risers and splitting the system. This is just an extract of the result of this high-rise building. Because investors are interested. It's not a commercial talking, we can be cheaper, we can, no, these are facts, open book. You could see the sprinkler design was ready, 904 tons water and pipe for that high rise in Cyprus, 171 tons with high pressure water mist. The people who are installing it, the light small pipes, they do it faster simply. And not just the installation cost will be lower, but the time, of course, because you need, instead of 8,000 nozzles, only 5,400 nozzles, because we can have bigger spacing to our nozzles. So it's not the question of one nozzle is more expensive or cheaper. We have to take a comprehensive overview of the project, and this is a nice extract of understanding the main parameters. The last two slides is just about to understand different countries has different standards. I face this, of course, every time. I'm new now to Latvia, and I'm happy if I can get some fire safety, fire codes from your region. Here, what you see, the Bulgarian one. The Bulgarian standard says, for instance, 28 meter is the dream for high-rise or not high-rise. That is 55 meter in Poland. There is on the right side. 50. So the same risks, high-rise. One is saying 28 meters, and then they are handling differently. The other country says, oh no, it's 55 meter. So believe me, it's a really complex way of understanding high-rise buildings. For instance, in Poland, we make fire simulation to reduce the fire resistance of the slab, the walls, the cladding. And using high-pressure water mist, the Polish standard allow you to make it on half. You could see instead of 120 minutes fire resistance, which is a big piece of concrete in a high-rise building, you can go down to 60 if you use high-pressure water mist and put a simulation. So this is driving simply the market also this direction. And also the Bulgarian, 28 meters, you see, it says the minimum fire resistance barrier should be 30 minutes, but 60 minutes, but if you have an extinguishing system, 30 minutes, the half. If the building is higher, more than 28, it says 90 minutes, but if you have an extinguishing system, you can reduce it. So I don't know your local fire code, but maybe this will generate some discussion. You can have questions after. And I think I'm reaching to my last slide, is just to tell you that we are here. Our partner, Sprinkler Service, can help you to guide you through in your native local language. So thank you for the listening to me. I don't know if you have any question left. If not, then I will have one. Because you might forgotten that I have some Grand Prix de Riga.
We could play it very easy. The one who asks the question gets the cap.
No.
All right, so questions with no prize. Anybody? Just put up your hand. Anything to ask? Really, everything is clear. Good. No. Yes?
I will clarify if everything is clear. So what is the minimum pressure to a high pressure nozzle?
Minimum pressure to a high pressure nozzle is
60 bars.
60 bars. Thank you.
Hey, welcome.
You have been listening. I've been looking on you. So Thank you very much.
All right, thank you, Márton. So, any more comments? Yes. And a little nice present just to remind you that you've been here. Thank you.
Thank you.